experiments that we're going to do. So the 3 simulations that we're going to do to record our observation and also to test our understanding on this fluid mechanics topic. Okay. All right. So you look at the lab manual. So it will be I think there's not so many experiments involved today. So I think you might finish it quickly. Okay. So we have the learning outcome for this experiment. So you're going to explore about the buoyancy of an object and relate that with the Archimedes principle. Okay, and you need to find out the factors that affect the buoyancy of an object. Okay, and also explore the pressure inside a fluid at different depth. So basically, you have different level of water, and then you need to measure the pressure, okay, at different level of that water. Okay, and also you need to analyze the relationship between the density of the fluid and the pressure. Okay, and then also you're going to use the Bernoulli equation, okay, to verify the fluid dynamic relationship. And lastly, you're going to need to explain the factors that affect the pressure and velocity of the flowing fluids. Okay, so basically the first two involved with the fluid, above 4, so that deals with the fluid statics. Okay, so where the fluid is at rest, and then the last two deals with the fluid dynamics where the fluid is moving. Okay, so that's basically about the fluid mechanics. Okay, so the fluid statics relate with the Newton's first and third law. Okay, so where we explore about the key concept of density, pressure, and buoyancy. Okay, and the fluid dynamics. Okay, so we analyze that based on the Newton's law and principle of the conservation of energy. Okay. All right. So we look at the first experiment about the buoyancy. Okay. So you can go to the following simulation. So you can open the page. Okay. So basically, this is the experiment for the buoyancy. So you just follow the instruction over there. Okay, so we have a question there. Okay, so you need to answer if we decrease the mass of object while keeping the volume constant, okay, what happens to the density? Okay, so this is simple, so you can answer that. Okay, so first we run the simulation. Okay, so we change the density of the object. For example, so over here we can change the object density, okay, whatever that we want. Okay, and also here we can change the animation speed, whether it's slow or fast. Okay, so for example, like this, I change it to 4 and I run it. Okay, so it's like that. It shows you that the object will float. Okay, will float. So it comes from the middle of the water and will float once we run the simulation, and then you can reset it. Okay, try to make it animation slower, and then let's say we have a lesser density and we look what happened, okay, to the object, and then we run. Okay, you can see that the object is pop up, okay, pop up to less density. Okay, due to less density, because it's when it's less density, meaning that it is having less mass, okay, in having less mass. So of course it will pop up, okay, due to a small amount of density compared to um, the greater density of the object. Okay, so that's the question that you need to answer. Okay, that's question that you need to answer for the number 3. Okay, and then number 4, all right. So you can also change, okay, the fluid density as well. Okay, let's say you make the fluid density smaller. Okay, you can see that the object now is going to submerge into the water. Okay, because of what? Because you can see that the density of the fluid now is similar to the object density. Okay, but over here, we need to change according to what is given for the number 4. Alright, so the object density should be 5 gram per centimeter cube, and the fluid density should be 0.1 gram per cm cube. Okay. Okay, you need to check show number, okay, and free body diagram. Okay, over here show number and also show free body diagram. Okay. So because of what? Okay, you can run it again. Right. You can see that okay, so you have the free body diagram over there. So you can see that the force, the buoyant force, you can see. Okay, you can see that when once you run it, okay, once you run the simulation. So it's like that. So you can see that the buoyant force and then minus the weight. Okay, so you get the net. Okay, the net force for that. Okay, so you need to answer all of those questions. Okay, so this is after that. So you keep increase the density of the fluid and then see what is happening. Okay, and see what is happening. Okay. You see that what is happening. Okay. That there is some change. Okay. Some change. Okay. To the okay to the force. Okay. So you look at. So basically you can stop it and then try to run it again. Okay. So you see that what is happening when the fluid density and object density are similar. Okay, and you see that the object is now floating inside the fluid. Okay, but it totally go down to the base of the box. Okay, so that's for number 5. Okay, and then for number 6, so you change the density again of the object and also the fluid. Okay, and then you got to answer all of those questions. Okay, so that's about experiment number 1. Okay, so I don't think it's gonna be a problem for you to solve that first experiment. Okay, now we look for the experiment number 2. Okay, so you need to go there to open this simulation. Okay, so it's about the pressure in a fluid. Okay, and then follow the instruction given. Okay, so let's go to the page. Okay, so basically you have 4 different kind of simulation over here. The first one, the second one, the third one, and the fourth one. Okay, so you can select first to display grid, okay, and atmosphere off. Okay, so basically you don't have the atmosphere. So you can drag around the pressure cloud. So this is the pressure cloud. You can drag around. So you can have many pressure cloud if you want. Okay, so you can drag around. Okay, okay, and then you can use ruler. So you can drag this ruler. Okay, take ruler and then you can drag this ruler to measure. Okay, to measure the distance of the water level, okay, or water depth. Okay, you can see that. So the ruler give you the water depth. Okay, and then next, so you need to fill out. Okay, so you can see that when you move around the pressure, okay, when you move around the pressure clock, you will see there's a different pressure of water. So as you go further deeper into the water, the pressure increase. Okay, so now you turn on the tap. Okay, so you see that the pressure also change. Okay, so why the pressure also change? Okay, so you need to relate that. Okay, okay, so you need to answer the number 3 question. Okay, and then you first next for number 4 you set. Okay, so you set the pressure clock at about 2 meters. Okay, so you set it to 2 meters. Okay, somewhere around that. Okay, and then open the valve. Right, open the valve, and then you see water will flow out. Okay, and then the pressure change. Okay, so you need to answer that. Question number 4. Okay, and then now select the okay, you see that there is a container. Okay, container for the on the left side and also the right side. So they are connected with each other. Okay, and then so you have okay, select to display grid and set atmosphere off. Keep the pressure clock at a fixed depth of 2 meters. Okay, so that's it. Okay, and then you check the pressure on the left and also on the right side. So you compare that. Okay. All right. So basically here you need to have two clock. Okay. So you need to have two clock because you need to compare that on the right and the left side. Okay. So you observe that what happened to that pressure. Okay. And then next, number 6, you drop the weight. Okay. And you see that how it changed the pressure. Okay. All right. Okay, and then for the number 7, okay, you reset all. Okay, so you reset, this is the reset button, so you reset all. Okay, and then select to display grid and set on sphere off and fill the tank. Okay, so you need to put again the pressure clock. Okay, and now change the density to different value, so you can change that into different value. Okay, so you observe what happened to the pressure. Okay, so you observe what happened to the pressure. Okay, say you want to fill that with honey. All right, so you fill that honey into the tank. Okay, and you see that you observe that. Okay, so if it is water, then it will be different pressure, and if it's a gas or it's a petrol, so it will be different. Okay, so that's for the number 7. Okay, and also check at different level of the water depth. Okay, okay, so number 8, so you set to the density to gasoline and pressure clock at the depth of 2 meters. So again, you need to have the ruler to check about 2 meter. Okay, so it's somewhere over there. Okay, so you need to answer that. Okay, then you from here and then up to here. Okay, somewhere over here. Okay, you change that fluid density. Okay, so you note that how does the pressure change, right? Okay, the last one. Okay, you need to go to the mystery fluid. Number 9. So you go to the mystery fluid. Okay, you can select 3 different type of fluid over here. So you have fluid A, B, and also fluid C. Okay, and then you need to check. Okay, so what's the ratio of the density of fluid A to fluid B? So you need to find out what is the set density. Okay, so you know what kind of equation that you can use to find the fluid density. Okay, and then you also need to know what is the density of the mystery fluid C as well. Okay, so that's basically the experiment number 2. Okay, so we go to the experiment number 3. All right, by the way, any questions so far? It's all clear? What needs to be done? Okay, so we look at the experiment number 3. So this one will be about the fluid dynamics. Okay, so fluid dynamics meaning that the fluid is moving. Okay, fluid is moving, and then we want to measure, of course, when it is moving. So we have the fluid velocity and also the pressure as well. Okay, so that's what we need to observe, okay, in this experiment. So you click on the link, okay, so it will give you to go to a simulation. All right, so we have the pipe on the left side and also on the right side. Okay, so and it is connected, okay, by a connector. Okay, so we look at the first question. So basically, you need to use the Bernoulli equation. Okay, so you need to use the Bernoulli equation to solve this. Okay, click run. Okay, click run over here. Okay, you see the fluid is moving. Okay, water flowing from the left to the right. Okay, and then you need to calculate the pressure and velocity of the fluid on the right pipe using the Bernoulli equation. So you need to use the Bernoulli equation to find that. Okay, so verify your answer. Okay, from this. Okay, so once you click the box and you see the pressure on the pipe 2, okay, verify your answer with this. Okay, whether you get it correct or not. Okay. Okay, and then you reduce, okay, number 3, you reduce the height of the left pipe. Okay. So reduce the height of the left pipe. Okay, so this one, you can toggle this one. So height number 1. So you can reduce that. Okay. Okay, and then see how does it affect the velocity of the fluid on the left pipe. Sorry. It should be on the right pipe. Okay, should be on the right pipe over here. It's not on the left pipe. Okay, so how does it affect the velocity of the fluid on the right pipe? Okay, how about the pressure? Does it change? Please explain. Okay, so please explain yourself. Let me take note about that first on the lab manual. Okay, so that's for number 3, and then for number 4, all right, so you need to adjust, okay, both weight. Okay, so you have H1 and also H2. Okay, you need to adjust that, okay, to obtain similar pressure as the right pipe, as in question number 1. Okay, as equation number 1, what is original pressure? Okay, what is your original pressure? So you can stop and reset. Okay. So that's the original pressure, and then you change this, okay, in order to obtain, okay, similar pressure as number 1. Okay, what is the pressure again? So the pressure again is 552,100 Pascal. So you need to obtain this similar value. Okay, but you need to change the height. Okay, So you need to do that. Okay, so you need to record both of these heights. Okay, so what equation that can use to relate this? Okay, so what equation? So you need to find out what kind of equation that need to be used. Okay, okay, once you have that equation, okay, choose different height on the right pipe. Okay, so you change this. Okay, and you see, calculate. Okay, so you need to calculate the height. Okay, the question is not complete over here. I need to change. So you need to calculate the height. Okay, okay, once you change this, you need to calculate the height of the left pipe and then verify your answer with the simulation. Okay, the height of the right pipe or the left pipe, and verify the uh, sorry, and compare your answer with the one in the simulation. Okay, so that's question number 4. I'm going to share you the updated lab manual after this. Right. Okay, so for number 5, so you need to next adjust the radius of the pipe. Okay. You need to adjust the radius of number. Okay, so you reset first. Okay. Adjust the radius of the pipe. Okay, you adjust to, so this is the radius of the pipe. So this is the radius of the pipe. Okay, so this is for the left one and this one for the right one. Okay, so the thing is, you need to ensure how to make the velocity in the both fluid to be similar. Okay, okay, so adjust that. You need to make that the velocity, okay, to be similar. Okay, so this is the velocity on the pipe 1. Okay, you want to make that velocity of this one is similar to that one. Okay, all right, so that's it for number 5. Okay, and then you see that you want to number 6. How could you make the flow of the fluid on the left pipe to be faster? Okay, how you could make it this one to be faster? Okay, increase in velocity. Okay, so you need to change. You need to toggle whatever is necessary over here. So you need to change in order to make the velocity of the fluid change. Okay, and state the factors of that. Okay. So you see that. So what kind of change that you can make to change the velocity of the fluid? Okay. So number 7, okay, if you increase the density of the fluid used, how will affect the pressure and velocity of the fluid in the pipe? Okay. So basically the pressure wave. So this is the question that you need to answer out of that simulation. Okay. Okay, so what happened when you increase the density of the fluid used? Okay, and also number 8, if you do this experiment on the moon, do you still obtain similar pressure and velocity as it is done on the Earth? Okay, so that's the two questions that is not using the simulation, but you need to think about that. Okay. All right. So that's it for the lab session for today. All right. So you have 3 experiments. Okay. So as usual, so you need to prepare for the lab report. Okay. And then it will be due in 2 weeks. Okay. It will be due in 2 weeks. Any questions so far? All right. So you can start doing it. Okay. I'm going to be here for the rest of the time. Okay. Until 11. So I'm going to be here. So, but I'm going to end this session. So you can just text me on the WhatsApp. Okay. If you need any help. Okay. So I'm going to end this session now. So for the attendance, could you all please turn on your camera? By the way, just as I mentioned, I'm going to share you the updated lab manual. So, of course, there is some of the questions that I just changed just now due to the incomplete statement. Okay. All right. So I'm going to count from 10. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Give me one more shot. Okay, thank you. All right, have a nice day and start doing your lab report. Okay, and do the experiment. Okay, Assalamualaikum and bye-bye.
Waalaikumsalam. Thank you, Doctor.
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 Doctor.
Yeah.